Hi, my name is Emily Farah, and for my Adaptations project, I will be presenting the barn owl and investigating auditory capabilities in navigation. So introducing the barn owl, also known as Tyto alba or the white night owl. It ranges from every continent except for Antarctica, which makes it the most widespread land bird, but species categorization is still an ongoing dispute among scientists. Some scientists consider that the subspecies should be considered separate, and some do not. But for the sake of just describing the adaptation, I will consider them as just Tyto alba. And they're about medium-sized length. They're about 33 to 39 centimeters in length, so about the average bird of prey. So the adaptation in particular involves their hunting methods because they hunt at night, which means it's dark and their vision is less useful. And since they're hunting smaller prey, which is usually small rodents, or depending on the location, it might be lizards or tiny lemurs, just things that are small and hunting in the night, that means that using vision is not quite useful. So the morphological adaptation is that they have asymmetrical ears and they take in sounds from different angles, and that allows them to have a much heightened sense of hearing. And they have specialized inner ear development, such as the cochlear nuclei, as you can see in the diagram. And the physiological adaptation that comes from this anatomy is that they have a heightened auditory processing of interaural time differences. They're able to localize sound very precisely. They have very specialized mapping of these time differences compared to other birds of prey, and it's an apomorphic adaptation, and it's specialized, and it's unique to the group of species, and it separates the processing of phase and intensity binaural cues, which are associated with the location of sound in terms of angle and elevation. And that's the specificity of how they're able to attain those differences in sound and have that really specialized ability. So we know that barn owls have excellent hearing that allows them to navigate darkness and hear very quiet sounds, but I'd like to further test speed in comparison to other birds of prey that also have very strong hunting adaptations. So I hypothesize that barn owls can most quickly compensate for vision loss when hunting by utilizing a heightened sense of hearing. The constants that I want to remain the same throughout the experiment, so it's not interfering with any other part of it, is the testing area should be the same, the blindfold material should be the same, the prey size and shape, the simulated prey size and shape should be the same, and the distance that the birds are released to fly above the ground should be constant as well. The positive control is that there should be an unblindfolded barn owl, because that way you want to test the effect that the blindfold has on the bird, and the negative being the other birds that aren't barn owls. Using a barn owl and other birds of prey as the members of the experiment, the ones I want to focus on are specifically the peregrine falcon, because it has such a strong sense of vision, and the marsh owl because it's known for good hearing, the northern hawk owl because it hunts during the day. All of these things have different abilities that are different hunting abilities that differ from the barn owl, and I want to see if anything can adapt to overcome the blindfold and how that will work differently from the barn owl. So the procedure is that for each bird, you should blindfold them in a way that doesn't obstruct the ears. If it's obstructing the ears, cut holes in the blindfold near those ears and release above one end of the testing field, and move a false prey at the other end of the field slowly back and forth, time from release to how fast it takes for each bird to catch it. And then test each bird unblindfolded in order to compare how much blindfolding affects the hunting time. Otherwise, you're not going to be able to compare the effects of the blindfold on each bird. So the potential outcomes is that if the hypothesis is supported, barn owls have a very quick and developed ability compared to other birds of prey to accommodate to sudden vision loss in a new hunting environment. Keyword being new hunting environment, because we know that, as with many birds of prey, being in a familiar place gives them an advantage of being able to catch prey more efficiently, even when inhibited. And if the hypothesis isn't supported, there might be a possible error with blindfolds on any of the birds, or owls still might need something else, like familiar hunting grounds, as I mentioned before, or a heightened sense of smell to efficiently hunt without seeing, which would be further tested. And the other birds tested have other sensory adaptations that barn owls do not, that could allow for prey location when vision is lost, such as maybe auditory adaptations, but in a different manner, which then would have to be further tested at the more anatomical scale, or olfactory, or just other different adaptations that could possibly allow them to compensate for being blindfolded. And that's when further testing would also be required beyond the scope of just this proposed surface level experiment. And that is all I have. Thank you very much for watching.